Today let us discuss this sum. It is given that two equal masses are placed as shown in the figure. Friction of the pulley is negligible if coefficient of sliding friction of the mass on the horizontal surface is 0.2 and if the hanging mass is just released from position of rest, what is the acceleration of the system. Okay, so first of all you have to understand what is said in the question and what are the forces acting in this particular system. So for that, see here two masses are there, two masses, this one and this one is hanging mass. Now the thing is that there is a pulley. Pulley means it's a wheel like thing. Generally you have seen probably it is used while lifting water from a well. Okay, like wheel like structure is there like this, then there will be some string attached to it. Okay, then one side there will be a bucket, so if this string is pulled down then the bucket goes up, right, with the water. So this pulley probably you have seen. Now the same kind of pulley is attached here and one mass is, this one is hanging. As a result, what happened is, since this mass is hanging, due to its weight it is given that the mass is going down with certain acceleration a. You have to find out this acceleration. Now one side of the pulley is attached with this mass, another side of the pulley is attached with this mass. This mass is kept on a surface, and since it is on a surface, in between the surface and the object there will be some frictional force. The coefficient of friction in this particular region, that is given probably 0.2. yes, this one, coefficient of friction is given 0.2. okay, so at this one surface, coefficient of friction means mu, that is 0.2. Now on this object we will have to see how many forces are acting. But one thing you have to remember, that whenever a string, rope, thread, anything is attached with two masses, or the two ends of that particular string is pulled by two masses, then what happened is, in the string there will be generation of some kind of force. We call it tension. T means tension. Tension is a kind of force, so its unit will be Newton, and this force generally it arises in string when it is stretched or pulled by from both its end. Okay, or maybe one end is fixed of the thread of the string and the other end is pulled. In that case also some tension will be generated on the wire, this one string. Okay, now see, another thing you will remember here, that the direction of tension at any part of the string is always away from the object attached to it. That means if this part of the string we consider, the object attached is this one, then the tension will be away from the object, not like this, not towards the object. See the arrow that I have given, away from the object. So this is the direction of tension. Okay, and since the whole string is attached between two same masses, m, there is no other mass is not here, only two masses are there and the whole string is attached between two mass. So at each and every point the value of tension will be equal, which is T I considered. Okay, suppose another example I am giving. Suppose there is a one mass is there, one block, one string, another mass, then string, again another mass. So in this case the tension in this part and the tension in this part will not be equal, because this part is attached between two mass, this part is attached between two different masses are different. So that is why this part, the tension at this part and the tension at this part will be different. But in our case the whole string is attached between two common mass. So if it is so, the tension at this part and the tension at this part will be same. But remember, the direction of tension is always away from the object. So if this is the object, this is the direction of tension. If this is the object, then this is the direction of tension, which I have already drawn here with some arrow, right? Okay, then this figure is given with the question. Okay, now see, since this mass is going down with certain acceleration, it will obviously pull this mass also with the same acceleration a. We have to find out this acceleration. Now see, in this mass how many forces are acting? Two forces, weight of the body and tension. Which one is greater in this case? Mg is greater or tension is greater? Both are opposite, huh? Obviously mg will be greater because finally the object is coming down. If it is coming down, mg should be greater than t. How much greater it should be? How we will do that? If we do mg minus t, we will get some value. What value it will be? ma, mass into acceleration, because with this much is the resultant force ma with which this object is coming down, and that resultant force can be obtained by subtracting tension from weight. So that will be our one equation, first equation. I have written it here. This equation I have written, this one, second one. Okay, mg minus t gives us ma, equation number 2. Now equation 1 I have written, that is for this object, first object. Okay, now let us see, for first object its weight is downward and that weight will be supported by the reaction force, it will be cancelled. So this one we don't have to write this force. Okay. Now the tension is this side, and since it is on a surface, the surface has a coefficient of friction of 0.2, it will have some frictional force in backward direction, because the direction of frictional force is always opposite to the direction of motion. So since the object is going this side, frictional force will be backward. Now since this side the object is moving, so that means the value of tension should be greater than the frictional force. How much greater? ma. Okay, that means T minus small f gives us the resultant force ma with which the object is going this side. So that's what I have written, T minus f equals to ma. Alright. Now frictional force, we have a formula for frictional force. F is equal to, what was that? Mu into R. R means the reaction force, and in this case, as I told you, that this is the weight, this is the reaction force, both will cancel each other. That means we can say that R is nothing but mg, weight, same only. Okay, so in place of R we can write mg, so finally we can write mu mg in place of F. So that's what I have written, in place of F I have written mu mg. This is given equation number 1. Now we will add 1 plus 2. If we do so, this t is plus here, this t is minus here, it will get cancelled. Then what else we'll have? Here we'll have mg minus mu mg, this side ma plus ma, we are adding, right? So okay, and then from this equation, mass, if we take mass common from these two value, then mg only we can take common, mg. So if we take common, here we will have 1 minus mu. 1 minus mu means 0.2, so we have substituted the value here. ma plus ma gives us 2 ma. Okay, then this mass will get cancelled, and 1 minus 0.2 gives us 0.8. okay, and this 2 will come down, g will remain as it is, 0.8 g by 2, the value is this one. Okay, you can try once, you can do the calculation by yourself. So the value comes as 3.98 meter per second square, that is for the value of the acceleration. Okay, so I hope this part is clear. Then this question, let us discuss, is given that a cubical block rests on an inclined plane with 4 edge horizontal. Okay, this much you just have to know, that there is an inclined plane like this. So on this inclined plane there is an object. Okay, this is the horizontal surface. Coefficient of friction is given mu. Determine the angle at which the block just slides. This is the angle at which the block just sliding down. So we know that what is the name of this angle at which the object just starts to come down. This is nothing but angle of repose. Okay, so your question is that you have to find out angle of repose actually, which is directly not mentioned. You are just, it is asked that the angle at which the block just slides, that means it is angle of repose. So we have the formula for angle of repose, that is this one, no, 10, you can do by yourself only, 10 theta is equal to mu. So theta you are asked to find out, 10 theta, mu is given how much, 1 by root 3. So 10, how much is 1 by root 3? Is it 30? 10 30, 10 30 is 1 by root 3. So theta will be equal to 30 degree. Understood? Okay, then in next class we will start next chapter. Thank you.